So there's probably millions of reactions in the world. We can't remember them all, but luckily they fall into several categories. So we're going to learn the 5 major types of reactions, and by doing so, we'll be able to predict the products of any chemical reaction, even ones you've never even heard of before. And some of them we're going to be able to predict whether or not they'll happen at all. So you can't just mix any old chemicals together and get a chemical reaction. Sometimes it doesn't work, and we're going to learn why. So how are we going to do this? We're going to do this by recognizing the reactants. So the first type of reaction is called the combination reaction. The regents will call it a synthesis reaction. These two things mean the same type of reaction. So to combine means to put together. So in a combination or a synthesis reaction, two substances combine to synthesize or make one compound. So here's an example, calcium plus oxygen. So a combination is always an element plus another element. In this case, it's a compound, but it's a diatomic element. It's a pretty small one. So calcium plus oxygen is going to make calcium oxide. You just smush the two together. You combine the calcium with the oxygen. Now notice I didn't put a little 2 here. There may be a 2 later. I don't know yet though. I need to figure this out from the charges. So calcium's in group 2, so that's going to have a +2 charge. Oxygen's in group 16, so that's going to get a -2 charge. These charges balance. +2 balances out a -2, so no need to crisscross here. So it's incorrect to write any numbers here. Okay, but this is not a balanced equation. We need to show that we don't create or destroy any mass. In this equation as it stands, 2 oxygens are turning into 1, and that's not possible. So we need to correctly balance this equation. So to do that, I'm going to write a little 2 here. That's going to give me 2 calcium oxides. But by putting this 2 here, I change the number of calciums. Over here I only have 1, so I need to put a 2 there. Now this one is balanced. Let's do another one. So here's another example. This is 2 compounds combining together. Pretty small compounds, but just like in the previous example, you just smush them together. So SO3 plus H2O is going to combine to make H2SO4. So the 2 H's come from this. Here's 2 H's. The S comes from this reactant here on the left. And then the O4 comes from these 3 O's combining with this O. And if we look at these numbers, this should balance. 2 H's, 2 H's, 1 S, 1 S. 3 plus 1 is 4 oxygens, 4 oxygens, so no need to balance here. So you can predict the products easily if the 2 reactants are 2 elements, like this example here, Mg plus N2. So the steps are pretty easy. You're going to combine the Mg with the N. You combine the elements but not the subscripts. Then you do the charges. Mg is in group 2, so that's a +2. Nitrogen is going to have a -3 charge. And then you check the charges and see if you need to crisscross. And this one I do. 1, 2 plus does not balance out 1, 3 minus. So I need to cross this 3 here and then this 2 there. So Mg3 and 2. And then the last step, of course, is the balance to make sure you're obeying the law of conservation of mass. On the right I have 3 Mgs. On the left I have 1, so I'll put a 3 there. And my ends are balanced. 2 ends on the left, 2 ends on the right. So the steps again are combine the symbols like we just did, the Mg combined with the N. Then rewrite the charges. You put them above your products. You cross if necessary, and then you balance. So these are the 4 steps that you should write down and follow every time you're doing a combination or a synthesis reaction. So next I'd like you to pause the video and in your notebooks try to complete and balance each of these equations here. Now in the second one I give you a little hint. We're going to assume iron 2 oxide is a product. We'd have no way of knowing, so we're just going to pretend it's iron 2. So again, pause this video, give it a try. When you're ready, unpause it and I'll solve them for you. Okay, here we go. And the first one, the first step is to combine. So we're going to combine the Ca and the Cl. And we're going to do the charges. Ca gets a 2 plus charge, Cl gets a -1 charge. Then we're going to check to see if we need to crisscross, and we do. So we're going to cross the 2 over to the Cl. And then we're going to need to balance if necessary. And I don't think this one needs it. We have 2 Cl's on the right, 2 Cl's on the left, 1 Ca on the right, 1 Ca on the left. So this one's good. On to the next one. First step, combine the Fe. We're going to assume it's iron 2 oxide, so Fe gets a 2 plus charge, and then O gets a 2 minus charge. There's no need to crisscross, those charges balance. But we do need to balance the equation. On the left, I have 2 oxygens. On the right, I only have 1. So I'll put a little 2 here, but this changes my iron, so I need to put a little 2 there. Okay, and the last one, we're going to combine the Al with the O. So AlO, Al gets a 3 plus charge, O gets a 2 minus charge. Then we crisscross, Al2O3. Then we balance. So I have 2 Als on the right, 1 on the left. So I'll put a 2 there. I have 2 oxygens on the left, 3 on the right, so this does not balance. So I need to bring them both up to an even number. When I have 2's and 3's, the quickest even number I can get them both to is 6. So I'll put a 3 here. 3 times 2 is 6 oxygens, and then a 2 here. 2 times 3, 6 oxygens, but that messes up our aluminum. So on the right, I now have 2 times 2, that's 4 aluminums. On the left, I still have my 2. I need to change this. This is why I suggest writing in pencil when you're doing equations, because you're going to make mistakes. So that's okay. We'll just erase that 2 and put a 4 in there. Okay, our next type of equation we're going to talk about is a decomposition reaction. So decompose means to fall apart. So in a decomposition reaction, one reactant breaks apart into 2 or more elements or compounds. So in this example here, I have NaCl, and I can decompose salt with electricity. So that will break it apart into sodium atoms and chlorine atoms. So chlorine is never by itself, it's always diatomic, so that's Cl2. So that means this equation's not balanced here. I need to put a little 2 over here, and that gives me 2 sodiums and 2 chlorines. Over here I only have 1 sodium, so I need to put a little 2 there. Now it's balanced. Okay, in this next one I have CaCO3 decomposing in the presence of heat. Remember, the little triangle means we're supplying heat, and it's breaking down into calcium oxide and something else. You need to figure out the something else. So we can figure that out by looking at the equation, looking at the reactant on the left here. It's basically like subtraction. If I take away a Ca and an O from over here, what do I have left? I had this C, that wasn't in my reactant, my product, and I have 2 O's, so I just write down 1 C and 2 O's, carbon dioxide. So this equation, let's check to see if it's balanced. I have 1 Ca on the left, 1 Ca on the right, 1 C on the left, 1 C on the right, 3 O's on the left, 1 plus these 2 is 3 O's on the right, so that's balanced. So we can predict the products if it's a binary compound, which means it's made up of only 2 elements. It just breaks apart into those elements. So H2O with electricity will break down into its separate elements, like H, but H is never by itself. It's a diatomic element, H2, and O, which is also never by itself. It's O2. So we need the balance again. We have 2 O's on the right, 1 on the left, so I'll put a little 2 here, and that changes my hydrogens. I now have 2 times 2, 4 hydrogens on the left. I need 4 on the right, so I'll just write a little 2 there. Okay, how about this last one? Mercury oxide decomposes in heat to its elements. It will break down into mercury and oxygen, but oxygen is diatomic, so we need a little 2 there, which will mean we need to balance this equation. I need 2 oxygens on the left, so I'll put a 2 there. That changes our mercuries. I need a 2 on this mercury over here, and now it's balanced. If the compound has more than 2 elements, you must be given one of the products, or else you'd have no way of knowing what it breaks down into. The other product will be from the missing pieces. Like I said, it's kind of like subtraction. So why don't you give these ones a try here. If I have nickel carbonate and I'm decomposing it with heat, I get carbon dioxide and something else. So that something else is just going to be what's ever left from this original reactant. If I take out a carbon and two of these oxygens, I'll have a nickel left over and one more oxygen, nickel oxide. In this bottom one here, if I subtract the carbon dioxide from this reactant on the left, I will have two hydrogens left over and one of these oxygens, so that's just water. So in summary here, we can recognize the type of reaction we're dealing with by recognizing the reactants. So far we've learned two types of reactions. In a combination reactions, you recognize two small elements combining to make one big one. Every combination or synthesis reaction will look like this. A plus B makes AB. So two separate things combine to make one bigger thing. Don't forget charges and crisscrossing or else you'll get the problem wrong. Your product needs to be correct, and that will only happen by writing the combining first, then writing the charges, and then crisscrossing, and then balancing. A decomposition reaction, you will recognize that by only having one big thing, one big reactant, decomposing into two or more small products. So they'll look something like this. AB on the left decomposes to make A plus B.